Hello, this is Gary Marr of Glendale Community College. This screencast is for my XIS150AB summer online students. And in this screencast, I want to talk about a block of logic that I created that incorporates many of the elements that are required as part of assignments 3, 4, and 5. Now, this particular video is going to be tagged with assignment 4 because that might be the most problematic, but it's also going to talk about 3 and 5, so please use this for both of the other two assignments that you'll have to eventually do. In the beginning here, what I've done is just put a bunch of comment statements. And comments are only used to document essentially what we want the program to do in plain English. So when we come back to this program to do maintenance on it, or if we gave it to somebody else, they would be able to look at our documentation and determine what the goal of the program was. So what I've done is I put some business rules in here. And you might also know that I've got double slashes before each one of these lines. Double slashes are typically the way the C family of programming languages create comments. C, C#, C++, Java, JavaScript. Python uses a pound sign. Well, the C family languages used double slashes, just a different symbol. So on the top here, I've got the name of the file, my name, what I'm going to be using it for, and then the business rules. These business rules roughly equate to what the skateboard problem has regarding the region of the country you're shipping to, the quantity of skateboards, the weight of the skateboards. I've got I've had the business rules expressed in some cases as constants, in some cases this is just rough comments, in some cases something that looks very close to what I would have for pseudocode. But this would be helpful before getting into the actual code to understand what the business rules would be for this particular application called sales receipt. The other thing I put in here is that typically when programmers start from scratch, not necessarily in this case where the program's developed, is that you normally want to start with what are the outputs and what are the deliverables that I'm trying to give my user, okay? And the user wants to see item cost, quantity, extended cost, sales tax, and total printed out at the end as a sales receipt. And then you think to yourself, okay, well, what are my inputs are going to be? In other words, what am I going to have to grab from the user? And of those items I have to output that I'm not grabbing from the user, like for example, extended cost, which happens to be item cost and quantity, okay, which I am going to be asking for the user to give me, but I'm not going to ask him to do the math in his head. I'm going to do the math for him, so that in fact is one of those calculation statements my logic must have, like total and like sales tax, or total sales tax and total. The other thing I put in here is something which is really related to probably, well, 4 and 5. I want to basically create a loop that's going to validate the input that I'm collecting until it's correct. So if I'm asking for a particular number to be greater than 0, or a particular code, or a particular region, it's going to continue to ask me that until it gets it right, or until I get it right. And if it's wrong, it's going to say, hey, you've got an error here, fix it. And then finally, the modularization. If you haven't gotten into chapter 5 yet, modularization is basically taking your application logic and trying to chunk it up into subtasks. So the easiest way you would do this is you might have a block of code that relates to inputs, a block of code that relates to outputs, and a block of code that equates to processing. And then you would call them in the order in which they needed to be processed: inputs, processing, and then outputs. There'll be a lot more of this in chapter 5, but typically the one benefit you get with modularization is that you kind of take a whole bunch of statements and organize them into sections or subgroups, and it makes it kind of like a divide and conquer approach. So it typically makes your application easier to understand. And when I walk through this code here, you'll be able to see what I'm talking about. All right, there's the start of my pseudocode. There are my variables. I'm putting the data types with the variables. I'm not really worried about this in a big way in terms of if you do this or not. Certainly putting the data types is very helpful for the person who's going to have to code this, but also I think it's fairly intuitive that I'm working with numbers here, and based on the name of the data or the identifier, I know that it's going to be numeric value. So I'm going to have a couple of values here which I'm going to essentially put as a constant because they're not going to change. I've got 4 variables, which I'm going to initialize -1, -1, and 0, and 0. The negative ones will be clear here in a minute. I've got a couple of variables that are just used as part of the processing. Now, this is where it's going to get a little bit different. I have a module here, which is a block of code, which is basically going to tell me if the value it's testing, which is going to go into this variable called innum when it's called, if it's greater or less than 0. Okay, let's leave that there for now. The next block of code, okay, is going to be a large while loop. It's going to continue to while as long as the Q flag is not equal to Q. Okay, so come back up here, and Q flag starts off as a small z, so that the first time this line is executed, it will enter inside the while loop. Okay, because z is not equal to Q. Yes, that's true. So true brings it inside the while loop. The while loop is going to have a series of nested while loops for every one of the inputs I'm grabbing. So I've got one here I'm grabbing for item cost. Okay, one I'm grabbing for quantity, and I think that's probably it. That is it. So it says while less than equal to 0, okay, and then double parentheses item cost. Okay, if that's true, it enters into the block and does the processing. If it's false, it jumps down to the next while loop. Well, it turns out that item cost was initialized to be -1. So when it hits this statement the first time, it says is less than equal to item to 0, and then item cost equal to number is equal to number or value of number -1. It would go to item cost less than equal to 0, and it would send the item cost value to innum. The test would be performed, and if it's less than 0, it's true. If it's greater than 0, it's false. Well, the first time, too, it's going to be less than 0, so it's going to return a true. Okay, so this whole value here is basically true. And we know that when we talked about while loops, if a while loop has a true response, it enters inside the loop. So that first value of -1 is kind of a bogus value, one that's going to cause us to enter the loop. Now what's the loop going to do? It's going to say enter an item cost, stored an item cost. Okay, then it's going to call this method again, or this module again, and ask it, is it less than or greater than 0? If it's if it's less than 0, it's going to give us an error message, go to the bottom of the while loop, return to the top. Let's say I gave it a value of -1 again. It would still test true, and it would ask me once again for a valid item cost. And until it gets a value that's greater than 0, it's going to continue to ask me for a new value, because input error, item cost must be greater than 0. So what this does is it prevents bad data from entering the application, which may cause it to fail later on down. It also lets the user know that they have an error in their input, they need to fix it, and it'll continue to show that error until they finally get it right. The same thing's going to happen down here with quantity. In fact, it's going to use the same module and pretty much the same logic as we used in this example above. It's going to call this module call less than equal to 0 again twice, once in the outer while loop and once in the if statement. And if it isn't greater than 0, it's going to give them an input message and ask them again for a new value. If it passes the 2 while loops, so it has 2 valid values for item cost and quantity, then it can do the calculations necessary to complete the task at hand. So here I've got some calculations that are being done. I'm going to print the sales amount out, and then it's going to reach the bottom of the loop. Okay, and essentially what it's asking me there is going to hit enter to continue or Q to quit, and then end while. Let's go back up here. Remember, this outside while loop said if it's not equal to Q, it goes inside the loop. But as soon as Q is not equal to Q, and Q in this case is equal to Q, so that's a false condition. So now it would say, okay, I must be done. I'm going to end. There's no statements after the outer while loop, and then finally the end of the pseudocode. Now this is also out there in Python. It's a good one to run in Python with a debugger in Thony. I give you this to help you with a couple different assignments that you have to do, and if you have any questions, please ask. Thank you.